So hello everyone, and welcome back to day 2 of our, can you see my screen?
It's muted. Window slide show.
Yeah, I don't know why it's showing. Okay, yeah. So hello everyone, and welcome back to day 2 of our session on photometry with LCO. Today we'll be actually handling data since we've gone through some basics yesterday, and so we'll go along with you. I'm sorry that yesterday I did not know that Google had a limit to the emails I sent, and that's why some people I think did not receive all the files, but we'll share them again with you today, and you'll be able to see what's happening with them. And yeah, so I will share those files with you and we'll listing. So let's go back. Okay, so what I'm going to do now is, yeah. So if you remember, yesterday we had stopped with talking about the Banzai pipeline, right? So the Banzai pipeline, like I told you, actually is the pipeline which is provided by LCO to handle their data, right? And the idea, hello, just mute.
Yeah, it's fine.
Okay, so we mentioned this thing. I'm getting a double sound. Yeah. So the Banzai pipeline, like I mentioned yesterday, what it basically, it is a double sound. Yeah. So the Banzai, there's a double. So the Banzai pipeline, like I mentioned to you, is basically it processes the data immediately when LCO acquires the data. It goes through this pipeline, which basically gives you the data in the form in which you can actually use it. The idea behind this being so that the user does not have to spend time in actually processing the data and getting it. So what happens is the data, first of all, there is what is called bad pixel masking. Yesterday we mentioned it to you that for CCDs, you can have some pixels which are faulty and they have to be cut off from the image. So you mask the image with the bad pixels. You subtract the bias, you subtract the dark, and you do the flat field correction, divide by the flat. And then what Banzai also does is it runs a source extraction software, which basically extracts sources, I mean, gives them their positions and their magnitudes. And the final step, which Banzai does, is it does what is called astrometric calibration. That means for every source, it gives you an RA and a deck, and it gives you the brightness, right? So what you actually have at the end product, which I'll show you now, is you have all uh, data, right, in the form of, first of all, you have it in the form of, you have your the bad pixel, the bias, the flat, everything that, and the source file, as well as you have the source extraction. That means you have the catalog, which gives you the thing, right? So that's what Banzai gives you. So like I told you, you have the final data products. The tables are in the form of fits files. There is a science, which is the array of the pixel science data. There's a bad pixel marks. There's an error file, which actually gives you the array of cumulative pixel uncertainties. And there's a catalog file. So specifically, if we are going to deal with, for example, star clusters in our case for HR diagram, then the catalog file is what's important for you, because it gives you, from the image, it extracts the sources. For each source, it gives you the XY positions. And because it has done using astrometry.net, it does astrometric calibration. So for each source, it also gives you the RA and the deck. It gives you the coordinates and the magnitudes, right? So that is the final product which you actually need if you are, for example, wanting to plot HR diagrams for star clusters. If you want to do something else, you can accordingly do what you want, because you have all the data available. So now what I'm going to do is I'm going to actually take you on to the site, right, to the archival data site, and we'll actually have a look at it. So if you remember, yesterday I had shown you this site. We can go on to it. It's the same site actually. Yeah, it is. Oh, here. I hope you can all see my browser. Can everybody see my browser fine?
Yes, ma'am.
Yeah? Okay, great. So this is my browser, And here I open this site which I showed you, archive.lco.global, right? I realized yesterday that if you if you not don't have an ID, you don't have complete access to the data, and that's why I have shared with you my ID. I will again write that down in the chat window. This is for everyone, right? I'm sharing my ID. So my login name either is, you can write P Hasan, or you can write, if it wants the email, you can write priyahasan@gmail.com, and my password is secret at 123. But I would request you all not to log in just now, because otherwise we'll have too many logins from the same site, right? So I'm going to just log in myself, and I have logged in over here, which you can see I'm logged in as P Hasan. Your password you'll have to put is just secret at 123, right? Now what happens over here is that here there is various proposals. Please click on even include public data, right? Because there's a whole set of data which is publicly available for users to use from there, right? Now, how do we use the archive? Now, I'm going to, for example, what you have to do is on the point window, you will write the object you want, right? So I'm going to write an object which I often use, which is M36, which is NDC 1960. So you will write the name of the point, and you'll put this search. And once you put the search, it finds out the array and the deck of this object which I'm searching for. And it immediately loads and tells me what is the data available for M36, right?
I have a question. Why it is
Yeah,
point and not object?
I don't know. If you put, these people have their own thing. See, we can try it out. If I put object, you'll see it doesn't do it.
Oh,
This item, it's doing it the old one. Ideally, it should be that, but it is doing it with this, right? So it actually, I don't know whether it's just giving the what it does is, if it did not understand what to do, no, it shows you the earlier screen, and that's why it's still showing you things. So you may think that this means that things are available, but actually they are not, right? So I'll just show you this again. You are seeing stuff, right? But that is just because I'm going back here. You see now here, if I write object M36 and it doesn't know what to do, it just shows no matching records.
oh,
Right?
oh.
But earlier when I showed you, it was showing matching records because it remembers what it showed earlier. And if the thing you search for doesn't have anything, it doesn't this thing. So just take it for these people's thing. Actually, yesterday even I was having a problem with this. And then I discovered that the object has to be called point, because the point is the one for which it's going to find out the array deck. This is their own, whatever, their own way of doing it, right? So,
And if you just put array and deck, will it work?
so if you see over here, it says that if it has written in the fits header, not an exact match, returns all frames with a distinct. So if in the header files of these, the object name is written, then probably it will find it. But probably all headers do not have it. So maybe that's the thing. So now here I've put this thing, and now you can see it's, why is it not finding now? Oh, sorry, I did not include public data. So I'll say include public data, and now it's showing me all this. Now, if you remember, I showed you that the data has raw and it has Banzai. So we need the Banzai data. You can, in principle, like I told you, if you want to make changes to Banzai, the GitHub page, I showed you the GitHub page, which is available. This is the GitHub page of for Banzai, right? And if you want to make changes in the Banzai software, you can make it by going to this page and running it on the raw data. But otherwise, we'll do this, and I'm going to sort this so that this just shows me the Banzai data. Okay. Now, what does it do with the Banzai data? So let us do this plus sign, right? And okay, this is see, these are the exposure times, these are the filters. Just so that we get a nicer filter, I'm going to take, this is a B band with 19.9 seconds filter. Let's look for a larger exposure time, but we don't have much. So, okay, we can be happy with 19.9. So this is a 20-second exposure in the B band, right? So now what it gives you over here is, it gives you, number one, look at this file over here, which is 91, right? It has 91, E91. This is the Banzai extension, which gives you the catalog file, right? So you will get array, deck, and magnitude. So the catalog file will be sitting over here, okay? The other option you have is, if you want, you can also download. You can download, this is the main science file, or the dark image if you want, or you can download any of these files which you want. We are going to do both those things so that you can have an idea of what happens. So if you view the header, this is the header for the information. This is telling you the object. This is telling you it's RA deck. You can see it's also, it will tell you the filter. If you go to F, the filter is B band. It's telling you the exposure time is 19.9. So it's giving you all the details about this thing, right? So what we are going to do today is I'm going to show you two things. Number one, I'm going to show you a simpler way of looking at this data. And then we will show you how do you see this data with Jupyter notebooks, because you may actually want to do some analysis with the data, for which it would be more helpful for you to look at these files using Jupyter notebooks. But first I'm going to start with the simpler version, and then we'll do the harder one. So let me tick this file, and then I'm going to tick all these files. These are all the image files, right? And then I scroll up, I say download, and it's going to download 6 for me. So I'll say download, and it's loading all these files, right? You can try doing it yourself, but obviously it would be better if you do it later on, so that we don't, end up losing on this thing. Come on, download. Yeah. So here it's giving, this is the date, right? This is 9th of October. So 2022-10-09-6, and you want to download these files. So I say save. It has saved these files. It's doing it twice. I won't let it. Yeah.
Can I have a question?
Yeah. Tell me.
When it shows sky flat and bias and dark, does it mean is a master calibration files, or
yes.
just
yes. So I'm just going to show that to you.
Master flat, master bias. Okay.
So if you want to view these images, there is a standard software called DS9, okay, Deep Space 9, and it's also called SAO image, right? So I would urge you all to go to this. If you just Google DS9 SAO image, this is also a Java-based thing. So if you click on this, you can easily download this thing, right? And download this software, okay? So you can do it. This is just a software which is available to view images, right? Now, I'm going to stop share, because I think I should share my complete desktop so that you see everything. I'm resharing. I hope you can see my complete desktop. Now, if I show you over here, remember I told you that the file name comes as the date 2022. This is 10th of October, 9th of October. So month is 10. This is the date, and 6. So it's a zip file. I'm going to unzip this file, opening it with the archive utility. So this is the unzipped file, which is this, right? Now what I'm going to show you is, first of all, I will show you the images. So I'm going to, for example, if I want to open the images, I can, if you take the 00 file, right? This I can open it. I already have DS9 installed with me, and therefore I'm going to open it with DS9. So if I open it over here, I hope you all can all see this. I'm sure you can see it. I'm opening this as the science image. Right? The scaling needs to be changed so that you can see the objects. Okay. So DS9 is a very interesting software to observe images. Now, if you remember when we uploaded this object, you saw nothing, right? You saw nothing, but then there are different ways of scaling images. So here I did a histogram scale with a min-max. I may also, you can see that we are just seeing a portion of the image. So I need to zoom out. So I may actually zoom, and I may say zoom to fit. So this is giving me the whole image, right? So this is a star cluster called M36 or NGC 1930, which you can see the whole image over here. If you have a mouse, yeah, you can actually adjust the contrast which you have on this and see this. You can also, with DS9, you can actually play around with it a little bit. You can change the scalings so that you can see it better. But like you can see that now when I change the scaling in these ones, I'm actually losing my object. In a little bit, it's coming over here in logarithmic scale, in linear, but you'll see that amongst the best ones you get with histogram, or you can take something called Z scale. But I've taken histogram and min-max. If I want to make changes, you have a drop down over here on top, where you have scale, this, that, so you can actually scale it using various components. We don't have lots of time today, but essentially if you play around with these things, you can actually scale it to your liking. There are, it's very user friendly. You can adjust these scales and you can put this all and get your object as you want. You can also add colors. This is a grayscale, but if I want, I can even use what is called a heat scale. I can use a cool scale. I can use a rainbow. I can invert. You see, this is my mouse. I can use my mouse and uh, adjust it to get my grayscale or whatever. So all I'm doing is I'm using my mouse to actually adjust it and get the contrast to the best value I like. So this is my science image which I can view, which was obtained after cleaning. If you remember yesterday, Hasan sir spoke to you about CCD processing, right? So what the Banzai pipeline has done is, for the data which we derived, it has actually cleaned the image. It has done all that business which is of bias subtraction, dark, flat fielding, everything. And this is the cleaned image of the cluster, right? So this is the cleaned image, which the Banzai pipeline has this thing. And I once again told you that in case you are not happy with what this does, you can download the raw data, right? From that same archive site which I showed you, you can do the raw data, download the raw data, and then run it yourself. But in general cases, the pipeline is good enough. So therefore, this one is your thing. If you want to see the header of this file, you just click on File and you say Display Header, and you can see the header. There are two files. So if you see the first one, you'll see this is a very short description. But if you go in for the second one, that is the one for this science image. You'll see the second one. You'll get a more detailed one. This is a much more detailed one, which we saw at the archive site also. It's telling you the size of the image. It's a 2K by 2K CCD. So, but some of the rows and columns are used for other things. You can see that this is giving you all the details. What is the RA deck? This is telling you which telescope was this observed from. We know that there are 25 different telescopes, but here you can actually get to know which is the actual telescope which observed this, what was its latitude and longitude, etc. The filter that it had, the exposure time, whatever more details you may want to know about this image are all available over here, right? So what happens is, here you have this image and you can actually see all the details about the image. All the other images are also here, right? Now there could be a case where this image would be useful for you or important for you. When we are doing star clusters or catalogs, that time these images are not very important for us, because what we need is the catalog. We do not require the image. We want the catalog, but we can use the image to actually upload our catalog. Yeah. So there's a question from Raghav Krishna. What's the unit of the value in the FITS file? Okay, thank you. So the FITS file is a digital image. If you remember yesterday when Sir spoke to you, a digital image is just a matrix of X and Y, and every pixel has a certain count. So these are counts, right? Because if you remember, the CCD is like a bucket which just collects photons, right? And as photons fall in that, it counts it, and that counted photons are going to be falling on every pixel. So therefore, if I can zoom in, I'll further zoom in. I'm further zooming in. So this is an individual pixel, and for each individual pixel, it's telling you the count. So you can see that this is the RA deck, which you can see flashed on time. If I don't want it, this is in hour minutes. I can even change it to, I can put it in degrees. So here now, if you see, I'm getting the RA deck in degrees. That means the RA is 84 degrees and the deck is 34 degrees. This is the RA deck. And what you see down, X, Y, these are the coordinates, and it's actually giving you the count, the value which is written 1070. That is the count of the pixel. Now this is very important because, yeah, just a minute, I'll just answer your second question, BJ. But the idea of this is that this is giving the pixel value, right? Now, if you remember yesterday when Sir spoke to you, he spoke to you that when you have a digital image, he will even show you today in a demo that if you have a digital image, you can do various things with the digital image. You can add images, you can divide images, you can subtract them, you can do all mathematical operations with an image. So the idea of an image, digital image, is exactly that you have a count, and you're going to use the count to do all kinds of image manipulation, right? Image manipulation. So BJ is, John Jasper is asking me, what do we do with DS9? So you can do a lot with DS9. First of all, you can display the image, right? Along with the display of the image, you can, for example, we don't have the time today, but there is what is called a catalog tool. You can overlay a catalog on this. So for example, if I click the catalog tool, I can actually look for, if I had a catalog of this, I can actually load a catalog which has the array and the deck and place it on top of this image, which I can show you all how to do it, but we can do it a little later. I'll just show you how to do it. And you can overlay this catalog on this. You can do various things of analysis. You can, for example, draw contours. So if I say I want to draw contours, I can click on analysis and I can plot contours. So it's doing the contours, but you see the contours are in such a way that they're covering too much. So I need to basically adjust the contour parameters. So I may adjust the contour parameters to, you see that the high level is, the highest is this and this. So you see these are the contour levels. So I may actually change the contour values. Supposing I take it to 1000 and I take it here. What was that 1070? So let's keep it as this. I can say generate and apply. So you can actually adjust this to get, look at these contours now, which I have got. So I've actually applied, I've actually got contours over here around my objects, right? Why do I not have one around this? Because you see, this has a lower value. This is coming over here. These guys are here. This is coming over here. So I can actually set contours onto this. I can display it. I can overlay it. I can also, there in DS9, you can make various frames. You can make a total of 16 frames, display things in frames and blink them, tile them. Actually, we don't have the time today, but there are many, many things you can do into display with DS9. So have a look at things online, and DS9 is a very, very useful tool. So you can display, do various things of analysis, you can study regions, you can plot things. You can also from here access virtual observatory. So if I have a table which I'm observing with virtual observatory, I can plot it on this. I will show that to you and you'll see that. Another question which I have from GR is, how do we convert count into Jansky addressing? Yeah, so you have to actually check up how to, you will, for the given CCD, you have to check what is its readout noise and its gain. That information is given to you in your header. So in your header, you will actually get all the information. What is the readout noise and what is the gain? So then you can actually convert it to proper counts. And once you have converted to counts, you will have to scale it, right? So if you want to convert to these things, you have to use it, you have to use things about the CCD, right? And you will then get to know how to use it. So this is the images. I'm sorry, I can't go into more detail about this, but there are loads of things which you can do it with DS9, trust me. Okay. The other thing from the data which we downloaded, if you remember, we downloaded this, and then I told you what is important. So these ones, you see, this is the bias, this is the dark. I can open these also and show them to you just for interest. So I can, for example, have a new frame, and in the new frame, I can open another file. I can import, for example, the bias frame, and this is the bias frame, which is loaded over here. Yeah, so I'm going to remove the contour thing because that contour thing is making a mess. But here you can see, this is my bias frame. This is the master bias. Okay. Similarly, I can make another frame, and here I can import, I can open the next file. This is my dark. This is the dark image. If you want to see what it looks like. So I will again show it to you in a Jupyter notebook what it looks like. I can have another new frame, and in the new frame, I can again open the last image file, which I have is the flat. And here you can see the flat. So now look at the flat over here. See, look over here, the value. This is all scaled to 1. So yesterday somebody was asking me the question is, why do you divide by flat? So have a look over here at this box over here. And you can see that ideally the same amount of light has been put onto the CCD. First of all, you can see these images over here. and these are basically dust grains on the CCD which are out of focus. Therefore, you see it like this, right? And next, what you can see is that for the same uniform illumination, you can see this pixel over here is giving me a value of, there's a pixel which gives me 1.1. This one is giving me 0.99. This is giving me 1. This is giving me 99. This one is giving me 0.99, whatever. So therefore, you see the response of every pixel is slightly different. It is not one. Ideally speaking, all of them had the same illumination, so they should have given you the same value, which is 1. But they are giving you lesser. So for example, if there is a pixel which is giving you 0.99 instead of 9, you divide the value which you observe by 0.99 so that you enhance it, right? Because you have actually decreased it because it's only giving you 99% of the light. So when you divide it by 99.99, it increases the value and makes it uniform. Similarly, this point, for example, here is giving you more than 1. So when you divide it by more than 1, it decreases the count of the object, right? So if you want to actually see it, you can actually put it like this. And here I'm showing you tiled frames. So this is our science image. Here you can see one was the bias, right? This was the bias, this was the dark, and this was the flat, right? I don't know whether you can see it well in the contrast, but this is the flat image. This one is the bias, this one is the dark, and this one is the object. So again, with DS9, you can actually observe all these things together. Supposing they were the same thing, you could overlay them also and blink them. This is, I've tiled them, but similarly, I can even blink the frames so that I can see how does it look. I can do various things with them. We won't go into those details, but in short, you can view all the Banzai pipeline output using this, right? Okay. Sir is going to show you Banzai pipeline output for another object, M51 for a galaxy, but here I'm showing you this for a cluster. So this is how you will actually view the images you saw. Now the next thing I want to show you is, if you see in what you download, there is a file which has an extension 91, okay, E91 fits. And yesterday I told you about something called TopCat, right? TopCat is something which we use to actually view catalogs, right? So if you just do TopCat, for me you'll get this. So if you don't go for the cartoon, obviously, go for TopCat Astrophysics, right? Again, like I told you, this one is also Java based. So you can scroll down from here and you can actually download the jar file, right? Only thing you require on your system, any OS will do. Only thing you require on your system is that your system should have Java, right? So you should have running Java. And once you have the system, if you're running it on a Linux system, you will have to say Java minus jar. I'll write it down in the chat window. You will have to say Java minus jar, TopCat. I think that file is called full.jar. Yeah. So if you download that, you'll do TopCat full.jar. If you're running it on a Windows machine, you'll just have to double click. If you double click, you will actually see it. Islam is asking me, how can one use this master file with this unclear frame? So with this master flag. So actually, since you're using Banzai, this is already done. You do not need to do anything. Okay? You don't need to do anything. You're directly just going to use the Banzai output. Do not worry about doing anything with it, right? If you want to, this is for higher level, if you have some objections or you are not happy with what Banzai is doing it, then you will use the raw data and do something. But otherwise, as of now, do not do anything with this. Just directly use the output of Banzai, right? Now, I already have TopCat installed. You can install it very simply. I'm going to start it, and therefore I'll just open my TopCat. TopCat. Yeah. So I'm opening my TopCat. Okay, so here you can see on my screen, I've opened TopCat, right? See, some of you all who've attended my earlier workshops, you all must be aware of TopCat because TopCat is one of my most favorite softwares. It is a virtual observatory tool which is used to look for catalogs, okay, to look for tabular data. So if you have data in tabular form, this thing. Excel is a very bad version of TopCat, but the functionality of TopCat is very similar to Excel, right? So it will let you actually see like a spreadsheet, and it also has very good capabilities of plotting. It can do plotting, it can do stats, it can do various things. So now with TopCat, I'm going to open my file, which is the catalog file. So if you remember, I had told you that this is the file we are looking. This is today's data, which we downloaded. This is 1009, that is 10th of October. And if I'll open this folder, here you pick up the file which has 91. Okay. These ones are images. You remember, this is the sky flat, this one is the dark, this is the bias, this is this thing. So don't take that. Take this 91 number file. And I say, okay. And immediately you see it opens 4 files, right? If you remember when we showed you Banzai pipeline. We showed you Banzai pipeline. I remember I showed you one. The first file it gives you is the science file, which you can see written over here. The second file you can see is the catalog file, which we are interested in. The third file we can see is the bad pixel mask. The fourth file is the error file. We don't need to worry too much about these other files. Only worry about the second file, which is the catalog file. Okay, so I'm opening the catalog file, and you see the catalog file is made up of table, right? It's a table. So you have the XY coordinates, you have windows, etc. This one, what it does is it does what is called a growth curve. That means it keeps on increasing the aperture. Okay, so first it takes a first aperture and sees the flux it getting in first aperture. Now you can see obviously the star is bigger, the first aperture is too small, and therefore when you see the second aperture is opened, you are getting more, you're getting more flux. Look at the flux in the first aperture. You remember yesterday I explained to you what is called aperture photometry. By aperture photometry, I mean you have a star, you draw an aperture, you collect the photons within that aperture, right? Yeah. And then you keep on increasing that aperture size to get the flux. So in the first aperture, you can see I got so much of photons, so much of flux. Then I increase the aperture, you can see I got 2.2 10 power 5. I further increased the aperture, the third aperture, I got 3.7 10 power 5. Fourth aperture, I got 4.9 10 power 5. It's increasing. Fifth aperture, 5.76 10 power 5. Sixth aperture, 6.31 10 power 5. And so I have all these different apertures, right? And using these apertures, I decide, we don't have time, but this is for the growth curve. It's telling you how does so if you were to plot this, you will see that the value of the flux is increasing like this, and then gradually it flattens out. Okay, it flattens out as the aperture size is increasing. So 5.76, 6.3, it starts flattening out. Initially, if you see the increase, if you look at this line, you see the increase is much sharper. We started with this much, which is 10 power 1, 2, 3, 4. Then you came back to 5. Then you come back more, right? You're coming here, and then you're coming here, and gradually it flattens. So as it flattens, you figure out what is the aperture, which is also called the FWHM, which is the full width at half maximum. And using that, we decide what is the brightness. And here you can see, as you scroll way ahead, you come to a point where you're getting the RA deck, right? You're getting the RA deck, and the magnitude is actually coming somewhere over here. So there is a magnitude here. Yeah. So you use this, and with this and this gives you various other outputs. These are also other important quantities. We won't go into those details, but there are other more important quantities of the object it has observed, right? It also applies a flag to these things, and it comes over here, right? So you can actually convert these fluxes to magnitudes by just doing 2.5 times log of whatever. So let us say let me take it with this outside flux. I may say new synthetic column. I'll say call it mag, and I'll call this as 2.5 times log base 10 of, let me call this flux upper 6, right? So now here you can see this is a magnitude column. So this has converted, you have to decide what flux do you want, what is this thing, and ideally I've taken this as this. So I'm just going to move this a little bit here so that it's sitting next to my RA deck. So what it's given me here is it's basically given me the magnitude in B. I will instead, where is my magnitude? Okay, I'll put it over here. I'll just write a new synthetic column. I'm going to call this B and I'll call this mag. Okay, so here you can see this is the B magnitude of the stars, right? Now, typically, if you want to, for example, look at this object with another filter, right? You'll have to go back to your archive, right? So this is giving you, in short, with this what I showed you was you had the RA dex and you had the B. So I can actually plot this. You see this box over here. This is a plotting tool, and I can plot this over here and either do XY or I do it with RA and plot it with deck. So with RA deck, I can see this object. Now in principle, I closed my SAO image. Let me open that again. I will just try to open that. Just a minute, okay? Let me just look at my file. This is the one which I opened with SAO image. Scale, histogram scale, and I'm going to zoom out. So in short, this is the thing which we are seeing. With TopCat, when we're seeing it over here, when you match it, right? If I want, I can overlay this on that. I'll show you how to do that. So I can, for example, with TopCat, right? This is my file. Just to make it simple, I'm sorry, I'm not making it very simple, but I will try to make it simple. I can overlay this catalog onto this image, okay? And for that, you will have to actually save this file. You'll have to save this file, the catalog file, as I'm going to put it in what is called the VO table format, and I may call it just the cat.vot. I put it over here. And now in my DS9, I can add the catalog tool, right? And here I can open the file. This is not the folder. I want the 6 number folder, which is this one. Here is my cat. I put it over here. And here you can see it's doing the wrong. I'll have to tell it to take RA here, deck over here, and it has plotted. No, but there's a slight shift. There's a problem. It is not shifted. It's not correct. So we need to do something more to this. So I won't do this. Sorry. Let's just avoid this. We'll avoid this catalog. There seems to be a slight shift between the two catalogs. So I'm going to remove this catalog effect. Okay. So in short, here we have our catalog. So I will just stop with, if you want to, for example, plot an HR diagram. After Sir finishes, if there's time, I'll show you. But otherwise, what you need to do is you will have to go to the archive. This is our B-band data. You'll have to go back here to the archive, look for data of this thing. This we did it with for B-band data. Now, supposing you wanted it V-band. You see here I have V-band data with the same exposure time. You'll click on this. The 91 file has the catalog. So if you want, you only click this so that you download this, which is the 91 file, which is the V-band catalog, right? download this thing. Sorry, I don't need these things. I don't need this. I am only going to, yeah, I want just this. So I just want to download, not for cancel. I don't want these things. It seems to have ticked some more things. I don't want this. Yeah. So what you're going to do is go in for V band of this thing with this exposure time. Take down this and you will download. What is the second file? Okay. You will download this. Right. So this will be my 2. We will have to unzip this file. So I'm going back to my data set. I am going to say it like this. This is what I just downloaded. I will unzip this file, right? And now with TopCat, I will open this. So I will say file, load table, and now I'm going to open this other file, which is the V-band data, right? So I scroll down here and I'm going to get this. I think this is in 2. Right? So now I can overlay. So here on this plot, I'm going to show you, I have plotted, 1 minute. This is file, this one, this is the catalog. So I'm going to plot. So this one is in our V band, right? And I can overplot table number 2, which is in B band. Right? So you have to actually match these files. There's a slight shift. If you notice, there's a slight shift. We will have to match these files and get them, right? So I will stop over here and I will hand it over to Sir because now he's going to show you yesterday what we tried to share. I'm just now going to add those files onto the chat screen because I'll stop share. He's going to show you how do you handle this data, not with TopCat and DS9, but instead with a Jupyter notebook, right? So I'm going to share the Jupyter notebooks, which I had mailed it yesterday, but because like I told you, Google had some issues, I'm going to now attach those files, right? So till then, Sir will then show you these things. Please download these system files. This is the one for LCO photometry. Okay. Then the other one, which I'm going to give you, is for synthesizing images, the CCD one. And here there's a sample data file, which is of standard stars, which is also there, right? So all of you all, you can please download the Python notebooks. There are 2 Python notebooks and there's 1 standard stars file, right? And I'll hand it over to Sir.
Should I do it with those?
Yeah, you can do with those or share whatever you are using, right? So he'll start and
Hello. Yeah, so I hope you can hear me. Can you hear me? And I hope my internet doesn't create much trouble today. Can some of you answer? But can you hear me?
Yes, we can hear you very well.
Yeah, yes.
Okay. Yeah, okay, fine. Yeah, so how many of you are familiar with uh, Jupyter notebooks and Python programming? Most of you are. In chat, if some of you can answer. Yeah. Okay, so, and if you don't, if some of you are not familiar with Python, you don't need to know much of programming. It's something very basic which you need. And the best thing with Python is, as you want a certain thing you wish you want to do, you can just uh, understand that module and work with it. So just for the this thing, completion, I would say it's better you install Python using Anaconda. So, and once you do an Anaconda install, you can do it for Windows, you can do it in Linux, you can install it in Mac, on a Mac, whatever. And once you have the Anaconda installed, most of the things work on it. And in case you have any issue, then you can contact us. But generally, it's a very straightaway process. So I will share my desktop, and if you notice, yeah, I hope you can see this. Yeah, so best way of installing is, if you want to have Python running and Anaconda installation on Mint or Anaconda installation on whichever Linux operating system you require, you can go to that location and download it. It generally gives you a file. So, for example, you can see for Windows, you can select Windows, Mac, or Linux. And in Linux, you can see which version you want, 3.6 or 2.7. So go for the higher one. And once you do that, actually it downloads a .sh file, and it's a script file. And when you run that through your bash or so, it installs the whole thing. And then when you are invoking it, you start from a terminal. I'll start a new terminal. And here, if you say Jupyter notebook, it's something very similar even on a Mac. And on Windows, you may invoke it through the command prompt or otherwise. So once you say Jupyter notebook and run it, it will open your Jupyter notebook. Okay. And it will open, say, in one of your browsers, the one which is there. And it will show you the location from where you have run. It will show the files which are sitting there. And there you can pick up for example, we have this LCO M51 Python file, and I click that and I get it. Okay. So Priya ma'am has shown you how to get LCO data from the same site. You can download, say, whichever object you require. What I have done is I have downloaded M51, yeah, the Whirlpool Galaxy, and I have downloaded in a specific location. I'll go to that location, and it is in my folder in the LCO data, and I've created. See, it's always better to organize your files in a way so that you don't have issues. So I have my folder where I have my LCO data, and you have the standard stars folder. I have M51 and so on. So here I have downloaded the zip file exactly from where Priya ma'am did. And once you select which ones you need, so I had selected in B and V filter, and I selected those which had larger exposure values. They are 61 seconds, 61 minutes, and so there is a 300 one which is there, and it downloads as a bundled up zip file, which when you unzip it, you can unzip the whole thing, and it creates all these files. And as you notice, when you blow them up, you have all kinds of weird names. OGG0M046KB 27200 bias, bin.fitch.fz. Yeah. So it's a good idea to rename them. For example, this particular file is this org0m40. These are the labels which are being given by LCO. So I would not change. See, for example, it is a sky flat bin 1xx1 b fits.fz. So the earlier part of the file name, I would, it's not necessary to do it, but I would suggest this will make your life simpler. So I will rename this part. I'll keep the sky flat thing as it is, but I'll call it say M51. M51. Okay. So similarly, I have done this E00. This is the science image. So one is in, so I've written M51B for the B filtered one, and M51V E0 fits.fz, right? So see, now these things are becoming very easy. M51V E91 fits, M51B E91 fits.fz. So as you have seen, this E91 has many layers in it, which we'll again have a look at it. But this E00 is the science image, and you can open it with SAO DS9, which Priya just mentioned, and you can see it's looking all blank and empty. But once you rescale it in logarithmic scale, or you change the color into heat map or cool, various things, you start getting, you can see the image, right? So you have this whirlpool galaxy, and you can see it in different artificial colors, and you will see this, right? So this is one way of seeing the file and getting the header information and other things. Okay. So the other approach is what we are going to look at. Similarly, M51VE00 in the V filter, I can open it with this SAO image DS9. So this DS9 works on Mac, it works fine on Windows as well as on Linux. So again, you see this, and I rescale it, and I take the histogram. Okay. No, I will not be able to, because it's going to create a problem. There's a flickering which is happening, but I will, at this moment, I will not try to look at change my laptop, because the whole thing will go for a toss. And you see, you notice this image of M59 in V filter, which we are seeing a line here, right? So on the CCD chip, these are all damaged pixels, right? These are all the bad pixels. So we have not got anything here. We have some light missing. So if your CCD has such issues, then what best can be done is you take the third image, you take an image and shift it and do it, so that the same part of your galaxy doesn't fall on this line all the time, right? This was not visible if you notice in the other picture. Okay, so this is through DS9, but we will try to do this same thing using a Jupyter notebook. Okay, so we'll share this thing with you. So this matplotlib, it's a library which is very good library for plotting all kinds of things, all kinds of data, functions, histograms. It's a very good module. So this percentage matplotlib inline, this command, it is not a very essential one. You can comment it too and everything will work fine. But it is advised to put it because then your images will come directly without a problem. They'll sit uh, in your Jupyter notebook. Okay. So, right. And then we do this from AstroPy. AstroPy is a module which is used for astronomy, doing astronomy with Python. So if you run this command from AstroPy, for example, I'll just move it up and I run this command, and in case you are having a problem and it gives you error, then you have to install AstroPy. For example, you have this command which says pip install AstroPy. Okay, so when you run that, if it is not, AstroPy is not installed, then your, yeah. So in my case, since I've already have it, it says requirement already satisfied, and it shows where is AstroPy sitting. It is in slash home Priya Anaconda and whichever, right? So, but if it was not there, then it would have downloaded, and it will ask you to restart the kernel. And to restart the kernel, like we saw yesterday, there is a button on top which says restart kernel, and it restarts it. In this case, since it was already there, there is nothing much which will happen. But otherwise, all that module gets loaded into your system. Okay, so if for similarly, if your there is a error which is coming for from Apple Pie, import APL Pie, and you are getting some kind of an error, module not found or so, then you will have to pip install APL Pie. Okay, so you can either do it through a terminal or you can do it through your Jupyter notebook itself, where you say pip install or conda install APL Pie. Okay. So in my case, I just did it yesterday before we had sessions on the system, and everything seems to be fine. Okay, now I read this data. I'm reading, as you remember, we had this E91, E91, and when I run that, I'll run both these things. So file, I'm saving it in to file name 1, and I'm giving the path between these inverted commas LCO data slash M51 slash the name of the file. Yeah, the M51B dash E91.fits.fz. Yeah, so remember I changed the name to make it convenient. Otherwise, I would have had to write the whole funny name which LCO gives it. And similarly, in the second one, I'm reading the uh, second file, which is the V filter M51B E91, and it has read it. Okay. Now I'm opening fits open file name. So it from this file name, this is the command, and this fits to be using this fits. This has been imported, as you see, from AstroPy.io input output thing. Okay, and I'm still storing it some variable name which I'm calling it HDU1. The name can be of your choice, but it is for me to specify the header unit 1 file open. And similarly, I'm opening the other one into HDU2. If you wanted, you could have called it HDUB, HDUV, just to make it clear that one is for the B filter, and the other one is the B filter. And then when I run the hdu1.info, .info is a function, and when I run that, it gives me information about this M E91, the first file, and it is showing that it has 0, 1, 2, 3, 4. It has 5 uh, these things in it, frames in it. The 0th one is the primary one. One is the science image. 2 is the catalog. 3 is the bad pixel mask, and 4 is the error, right? Similarly, I can get it for the other file. Now, if I have done this, let me add another row here, and let me call, say, let me, what would happen? Here, let me call this file file 3, and I will put this LCO data M51 and M51B, and let me see what's the name of that file. I'm looking at that E0 file. So documents, LCO data, M51, and yeah, this is the one I'm looking for. M51B, M51B dash E00 dot fits dot fz. M51, yeah, the name, all this should be fine. And I'm reading this. So to run it, you have to press Shift and Enter. And now if I look at I'll store this in HDU3 and fits.open and file 3. Yeah, this is the one I'm reading here. And the only thing I'm trying to show you is, if you look at the information for this file, HDU3.info, you will see that it has this primary and one science. Yeah, so basically just it doesn't have the other details which the other file has, right? The E91 has the primary, science, catalog, bad pixel marks, error, etc. and etc. Right? Similarly, yeah. So E00s which are there in the LCO, they just have the science image. And there is a primary header which gives you some information about that. Okay. Now, since we have seen that these have 5 different ones, you can see that HDO1, 1, HDO1, 2, HDO2, 3, and you can see the headers of that. And it gives you the whole header of the thing. Okay. So So we'll run that, and it is giving you the header of the first one, the second one, and so on. Okay, and as you have seen, we'll convert these to the world coordinate system, and I'll saving it into a variable called WB. Since it's a B filter, that HDO1 is the image of M51 in B, I'm calling this WB, and I'm getting the coordinates, world coordinate system for that. And similarly, I do it for the V, and then I convert these to the x1, y1, x2, y2, right? So that I can plot it as an array. Your x1 is HDU1 2.data.field 0, and y1 is HDU field this one. Okay. And similarly, I do it for the second set. And then when I run these, yeah, so you can see when I'm saying show grayscale, yeah, I'm saving this figure as due to 1 in F2, and when I say F2 dot show grayscale, it is giving me the image. Okay, because I'm looking at the I'm looking at the one HDU1, which is the science image. Okay, not the 0th one, but and you can again see through DS9 we had observed that this bad pixel, this whole row of bad pixels is given here. Okay. Further, if we use the, you will notice that when we looked at the information, we noticed that there was a catalog file also. So if you see the, the catalog, which has the source, there's an SEP which does the source extraction, and we want to plot those objects here. This is going to read it from the catalog file, and what Priya ma'am showed you on in DS9, you will see here that those sources which are there in this appear on this screen. These are the sources which are there in the catalog file, and they get marked here with whatever color and all you specify. Okay. Now, looking at the error file. See, yesterday somebody was asking about the error file, and you notice that the fourth one is the error one. So if I look at the I look at the HDU1 and you can actually plot the error file also, and what you will notice, it is it will be a matrix like all images are, and it shows you the range of what it is, and you can even plot that. Okay. Right. So yeah. For example, look at this. I have the same thing. Matplotlib inline import numpy as np and import matplotlib pyplot as plt. And from astropy, I'm importing these fits so that I can read fits file. And from this utility, I'm reading this M51B E91, and if you run the info, we are getting these 4 ones, and I am storing the image. The image is the one is the image, so I am storing image data HDU list 1 into the image data, and when I run and see what type of that file is, if I am trying to find out the type of image underscore data, it shows that it's a NumPy array, right? And it has so many rows and so many columns, 2042 by 23046. In fact, you can even, you can in fact print this image data, and you see that the basic images, you'll see it's a matrix, and these are the numbers which are stored in each pixel, right? So it is okay. So the images are nothing but matrices with some values there at each element. Each element in the matrix is the count which we have in the light which has been gathered by a certain pixel, right? So similarly, uh, I can look at the image error file and HDU list 4. The fourth one is this one, and I am storing it here. And if I try to see what this matrix is, I can print this. Either I can print this or uh, I can plot it. So see, when you see this error one, it is again the same size as the image, but it is giving you the errors at each pixel, 24.70261. Right? These are this is the error file. Okay. So if you go to the LCO site, it will show you, it will give you the details of what each one is, what do they mean by these errors, what are these. Okay. And again, if I use this command to look at the type of this image.error, what I notice is it is again a NumPy error of the same dimensions as the main images. And I can plot this, and what I see is uh, the error one. Yeah, the numbers are very small, hence we are unable to see this thing. But what we can do is we can change the scales and plot it and get a image, right? So, for example, I have that image data file. I'll plot the image, not error this time, but I'll plot the image data. This is where I've stored the image in the grayscale, and you are essentially unable to see the galaxy, right? So what we can do is we can use this log normal exactly as we did in DS9. You can change the scale and do it. So one way of doing it is from matplotlib colors, we import log norm, this function, and then I plot the same thing with the log norm. And if you can see that, you can see these features, you can see the galaxy appearing here, right? In fact, I can do something even better. I will find out what is the minimum, what is the maximum, the NP minimum of the image data, NP dot max of the image data, mean of it, and standard deviation. Since these are just numbers, I can do all kinds of mathematical operations, and I will calculate the which is the least value in the whole matrix, and it is minus 3,004, uh, yeah, 34,046.51, and maximum is 18,892, and so on. And the average mean is 295, and standard deviation is 51, right? So using this, if I again use the same command, plt.imshow, and I say image data, and I set these, change the V minimum as minus 10, V maximum as 900 or so, and I take this color map as gray again, and I run this, I will see the features appearing here, right? I hope you can see it on your screens. And by varying this range, you can change it to 800, somewhere around the, yeah, you can see these things. And you can also change the color map, exactly like you could change it in DS9. You can change it to different C maps which are available. One is this jet, and one is in grayscale, and so on. So you can Google search and see what are the, for matplotlib color maps. So they have a very big range of color maps which we have, and you can uh, you can change these color maps, and you can change the maximum and the minimum and get the features out better. Okay, and as mentioned, these images, see, one thing is we are plotting these images, and you're getting a, you can see the image actually, or you can view them as a set of numbers. You can see these are nothing but a set of numbers which are basically amount of photons which have been connected at each pixel. So if there's more light there, there's a bigger number, and if there's a lesser light there, you get darker one, and so on, right? So from 0 to whatever, you have these range, and once you can imagine that these images are nothing but a set of matrices, then you realize that you can add them up, you can subtract them, you can divide them exactly like you do with matrices, right? So let's see if there are any questions. Am I clear to you all? Yeah, Priya. Is it clear? Can you hear? Sound is
Yeah,
there?
I can. Yeah, so
Okay.
please post
Yeah.
your questions. Yeah.
Yeah. So if you all are not familiar with Python, uh, we can have other sessions with that where we can carry you right from installation onwards. But it is not at all difficult to try it. And once you start off, you can start building over that. Okay. I hope you have got the basic idea of what is being done here.
Yeah, please post your questions. We'll give you some 5 minutes to post your questions.
Yeah. Are these visible, Priya? There's a change which is coming in. Not much. Yeah. So you can, in fact, you can go and search for matplotlib CMap. Yeah, and it will show you what are the different color maps which are available. And by changing those, you can see them in different filters and so on, different color maps. CMap binary underscore R. Yeah, then you can have these commands. There are many different options which are available, and you can always see those things and use them. If not, the default values are used. Okay, and there's a lot of help which is available. Plasma.
Yeah, there's a question. Okay. Which analysis method? Nitin, can you switch
Yeah,
off audio? Which analysis?
just a minute, Priya. It takes time.
Which analysis method is more efficient, Jupyter or DS9? And how should we select which one to you depending on data? So
Yeah,
Dhanraj is
okay.
asking this. So see
Yes.
the
You can close your step. See, the advantage with the Python method is if you're doing it through the Jupyter notebook, then you can create a whole pipeline and you can run it. You don't have to run the commands individually. For example, if you are doing it with DS9, you have to individually keep tweaking around, playing with each and every option. But here you can create a Jupyter notebook and you can just keep changing the files and the whole analysis can done. So this Python method, though it appears to be a bit difficult initially, but in long run it becomes very convenient because this can help you handle many files at the same time. You can program it, and you can read a set of files right away, many of them. So you can automate the whole thing. And so initially it may take time for you to get a hang of it, but in long run, this Python using the Jupyter notebooks or you can use Spider or whichever, that will make your life much more simpler and convenient. Okay, you want to say answers? You want to add on to this?
so Chioma is asking, I didn't get you correctly. If one decides to use Jupyter Notebook, which data can one use, the Banzai or the raw? So in principle, you can use either, right? If you want to use the Banzai data, then you like which was shown to you in the demo today, you directly actually it is best to take the Banzai data, but it is because it has obviously been done considering all the nuances of LCO as well as all the things. So you can kind of trust the Banzai pipeline, right? It is done by people who are more aware of the system than we are, and therefore it is good to use the Banzai pipeline. And like what we showed you today was that you can use it with Jupyter or with TopCat and DS9. The basic difference is there are some students, I mean, since there's a big range of audience which we have for this workshop, some of you all could be amateurs and not exactly people who are comfortable with coding. Then in that case, TopCat is far more comfortable because it's icon driven, button driven. You don't have to know any coding at all. You can just do it directly with TopCat or with DS9. But some of the participants which we have in this workshop are actually students from undergrad, postgrad level. And such students, they are familiar with Jupyter notebooks because nowadays it's part of the curriculum. You are using Jupyter notebooks in your normal, in class, etc. And so if you're comfortable with Jupyter notebook, then the advantage is that, for example, if you start some analysis with a Jupyter notebook, you can always tailor it for more than one data set. You have much more flexibility when you are coding it in the way you do your plots. If you do it the plots with TopCat, then TopCat will define how to do the plots, right? So you will have to do it just the way TopCat does it. But if you do it with a Jupyter notebook, you can design your plots to be different. You can do some more kind of analysis which you think could be relevant depending upon what exactly you are doing. So the idea of this workshop was to actually show you both these pathways. Either you do it with TopCat coupled with DS9, or you do it with Jupyter notebooks, with Banzai or with RAWs. Like I said, safer doing it with Banzai. So you actually can use it as it is, right? YB mergers asked me, I don't know why it is behaving that way at that step. What happened at that step? I don't. Okay, you put a screenshot. He has put a screenshot. Just see his screenshot.
Where did you put it?
In the chat. Okay. So your basic problem, YB, is that this APLPY, this software of yours has not been installed. So what you will have to do is you will have to add a line, you will have to add a box. So I can show you that, for example, you will add a box like this.
Pip install.
Yeah, you basically have to add a box where you'll say pip install LP, whatever. What is that software called? ALPLY, right? You'll have to add a pip install and run it. If you do that, then you will not get that error. So what's happening in your case, YB, is that your thing is not running because if you look over here, you need to use the software which does not exist. So you have to do a pip install, right? So you can see the command given over here. Where is it? It is pip install. You'll just have to type this somewhere in the beginning, okay, and run it. And then after that, when you come to the box which has this, it will do it. So please try doing that. It should work. Tell me if it doesn't. Chioma asked me, okay, yeah, fine. Akhan Hanif asks, is it possible to remove that NLI? No. So that error will go if you install that ALPLY. Once you install that, which is being shown to you on the screen, then you will not get this error message coming. Right?
See, in my case, when I ran this, it's showing requirement already satisfied.
Then see the other error now in the chat box. How do you download raw data from LCO? So exactly where I showed, archive. From the archive itself, you choose raw data and you can download it from the archive itself. Okay. Take it from the archive.
Priya, can you hear me? Sound is gone. Your sound is gone.
Okay. Yeah, okay. So don't use that f.f show, rather use this, what I'm giving you, plt.imshow. and in that give the file name and the CMAP, whatever you want. Yeah, grayscale or normalize, use the log normal and then do it. So use this from matplotlib. plt.imshow is a better one. Do it with that because there's much more flexibility which you have here, where you can change the maximum minimum range. You can use different, normalize by different techniques. So I hope when you do it, it will be fine.
I have a question. There was a question in the chat that there was a line on the image of the galaxy. It's actually not a bad pixel. It's a satellite track.
Okay, okay.
Which is now a very usual thing. It
Okay,
could have
fine.
been an asteroid, but it is too straight. Asteroid usually is not that straight. It's a bit wobbly. I get
Yeah.
this image. I get these lines all the time.
Acha, you may
And
be right. Yeah.
in principle, it is possible to remove them with image processing, but since it is at an angle, it is very difficult to do it. The straight lines, like horizontal or vertical, is possible. There are codes like that. My colleague from Slovakia, he developed the code to remove the bleeding lanes.
Okay. Yeah, this slide which you see here.
Yeah, but at an angle, it's very difficult.
Yeah. Okay, it's a satellite train. Possible. Because this train is not there in the other filter. When I plot the other one, I don't have this line.
Exactly.
Yeah.
So that is the method. That is also the way to check.
Yeah. And then another way we could have tested is if I plot the back pixel one, then let me try to plot the BMP and see what if it's there in the back pixel. See, when we look at the header, the third one is the one, right? So if I take the HD one, I if I can convert this to the third one, the 3, and then do it, and if I still have that, then it will show that it's a back pixel, but otherwise it should not be there. Yeah. Okay. Thank you, Rita.
If you want to make a beautiful picture, then it is possible to remove this pixel by pixel by using emedit. Just to make beautiful picture. But then when you go into the galaxy, then scientific data may be lost.
Yeah. Yeah. Okay. Okay, so
let's have more questions. Okay. Yeah, so Mariama is, yeah, 1 minute, there's this thing. Dhanraj asks, can we have some projects with LCO data? Yeah, I'll just do that once this part is over. And Mariama asks, is it possible with LCO to get catalog that can help us learn some parameters of RG stars? It depends on what parameters you want, Mariama. Because the catalog which Banzai creates, it's
okay.
It basically creates array deck and magnitudes, right? That is what Banzai creates. What is the parameters you want for RG stars, Mariama? It depends upon, so the basic catalog you will get, LCO will give you. So you can look for RG stars. If you know their coordinates, you can actually use that archive thing to, put in the values and look for the objects, right? Or you can actually observe them yourself if the data is not there. But you want mass and luminosity. Okay. So mass and luminosity, you have to derive it. Okay, you will not get that from LCO data. LCO data is going to give you the magnitude, right? But now you have to find out what is the you remember what I showed you, 4 sigma 4 pi r squared t power 4, as well as you need to know the distance. So you need to get the distance to your stars, that you convert it to absolute magnitude, and then you can convert it to mass and luminosity. So you have to do that with this data. But directly LCO will not give you mass and luminosity. You have to find that out. You cannot get that directly from LCO data. You use that and then analyze the data to get the values for that, right? So Mariama, you'll have to actually do that. Okay. Raghav Krishna, we are actually Global Sky partners for LCO. So that means we have access to the 40 centimeter telescopes. And like I mentioned yesterday, the 40 centimeter telescopes only have photometry on it, right? If you want to use the spectroscopy puns, you have to use the 1 or 2 meter telescopes, for which you need to separately send a proposal to them, telling them you want to observe something or for some reason. But there are many, many archival data sets. So in LCO also you can check in the archives if if there is spectroscopic data available, it will definitely be available. But other than that, there are many more archives. For example, SDSS, Apogee, Gala, there are many, many ESO, many archival sites where you can find spectroscopic data. But for spectra with LCO specifically, you will have to send them a proposal for what do you want to spectra for, using their 1 meter or 2 meter telescopes. We do not have access to that, so that has to be done separately. So essentially you have to build up a science case as to what is it that you want to observe, why do you want to observe it, and what do you expect to do with it, right? So once you get a science case in anything, even if you want to observe it James Webb, you basically have to put up a proposal with a science case. And if your science case is considered valid enough, important enough, then in that case, you can actually use that to get your stuff, right? But that has to be done only if you have your proposal. So I'll finally, yeah. So I'll finally wind up with the question which we were, Dhanraj was asking about LCO data for HR. I had almost started talking about that, but then I had stopped. So I will just once again show that to you. If you remember, when we had downloaded, I just plotted it and checked it. I will remove this thing. Yeah. So if you remember, when we first downloaded the B-band data, you remember this is the catalog for the B-band data of M36, right? So if you remember, I had shown you that you can actually do this. You can find out the B-band magnitude by taking 2.5 times log base 10 of the flux, right? So you take up the flux of safest is to take for aperture 6 because that's the largest aperture in which you can get it, and for that you can actually calculate the flux. So if you remember, I did this thing for calculation of B. I will just show it to you once again. I had taken the B band as, if you want, I'll show that to you. How do you get that? You'll take 2.5 times log base 10 of the flux. So if you actually look at this file over here, I can see this, and you take the flux upper 6. So I'll say flux upper 6, right? And this gives me the B band magnitude. So here's my B band magnitude, which I derived, right? Now, if you want to plot an HR diagram, Dhanraj asked for that, then this is your B band magnitude, but you also need V band magnitude, right? Now, if you want the V band magnitude, you will have to go back to the archive. Here is our archive. So this is the archive over here. And if you remember, this is M36. I want V band, right? And therefore, what I'm going to do is I look at this list. This is B band. Here is V band, which is with 19.9, which is exactly the same exposure time as the B band, right? So therefore, what I can do is I can expand this. This is the Banzai data, right? And like we did previously, 91. These are the files which have the catalog. While over here, these are the images, right? This is the exposure. This is the exposure. This is the flat, the dark, the bias bat pixel mask. So all these are there. We do not need this because we want to plot an HR diagram. So I will just click this. Okay, I will click this and I will say download. So I can just download and take this file. Right. So I can download this thing, and I've just downloaded it a short while back. So you click on download and you will download this file. Once you download this file, this is a zip file, which is over here. So I open the zip file and I get this file here. So this is the important file which we want, which is the 91, right? This is the 91 number file. Now I go back to TopCat, right? And then I open this file. So I say load table and I open this file, which is sitting for me over here, right? So please find this file, we'll load it, we'll say okay. And immediately over here, it loads you 4 files. So the 1 to 4, these 4 files were what we had for B band, right? Which is the catalog for B band. Now 5, 6, 7, 8 are the files which we have for V band, right? So this one is a science one, this is the catalog one, this is the bat pixel mask, and this is the error. So I'll go to this file, which is my catalog file. I open this file, and now I've got to find out the V band magnitude. So what I'm going to do is I have RADEC. You right click in TopCat, say new synthetic column. I'll call this V, right? And here I'll call this 2.5 times log of log base 10 of flux upper 6. Okay. So now this is converting this thing to magnitudes, which is my V band magnitude, right? So now in both these files, I have file number 2, which is the catalog for B band, and file number 6, which is the catalog for V band, V for visual. Now what I need to do is, one of the good things which is there in TopCat is look at these matchsticks. This basically matches 2 catalogs. So I can click on these 2 matchsticks, right? Here I take file number 2, right, which is my catalog in B. And here by default it finds out. It says this is the RA and the DEC. I match this to my file number 6 and I do it to my RA and DEC. So I say join tab symmetric, and I want 1 and 2 because you can even match it such that you take all of 1s or all of 2s. But the problem is I don't gain anything if I do not have the B with the V band, right? For my HR diagram, I need both the magnitudes. If I just have B band, that doesn't suffice. So I will say 1 and 2 and I say go. So now it's matched it. Now you can see over here, it said the matching it has done for 204 stars. Let us just view in this file 2, which is the B band, I had 206 stars. And for V band, I have much more, I have 456. And therefore I have 206 stars. If I wish, I can, if you look at this match, we matched it and I got 204. I missed out on 2 stars. I can, if I want, I can increase this thing. Let me increase it, supposing to 5. Okay. But when I run it with 5, again I get 204. That means increasing it to 5 did not improve my results. So if you remember when I had plotted initially the RADEX, you remember there's a slight mismatch between these 2 fields. That's why maybe 2 stars are not falling within the field. So if we are taking 1 arcsecond matching, that is fine. So we have only 204 stars. Now let us look at this file, which is this. So you can see my B band magnitude. The table is called B1A. And this one is called V, right? So therefore now if I want to plot the HR diagram, I take this plotting tool. My X will become B underscore 1A. Score 1A minus V, right? There's only a slot. Actually, there's a negative sign which comes in. Therefore, this actually becomes the opposite. This becomes minus B plus. I should have done that negative sign because the magnitude scale is this. and I get this, right? So here you can see this is by B magnitude and this is my V magnitude. So here I've actually already did this, so you have this like this, right? And this is my HR diagram. So in principle, what one can do as a takeaway from this, I'll just answer these questions in a minute. As a takeaway from this, what you can do actually is to pick up star clusters, right? Or any, pick up star clusters. You can actually see catalogs of star clusters. There are various catalogs available. I can share and show you. Let us do the desktop only. So if you share and see, you can actually get various star cluster catalogs. Right? There is this one which is called the Milky Way Star Clusters catalog. There are various other catalogs. In these catalogs, you'll be able to see the name of the catalog. You come here, you will actually get the catalog. This is from this year, right? So, one second. So you're going to get it in tabular form, which is like this over here, which is the name of the cluster, RA deck, etc. You will get all that together. So how you actually need to do this is you can use this reference, right? Let us go to this one if you want, 2015 paper. Let us go to this. Click on this. Oh, okay, or even better, go to this. Let me go this, or you can get it from here. You go it from here. This is another one. Let's not do this catalog. You can actually say here, you can click on this straight away and here, and from here you'll actually get catalog.dat, which is the catalog number, the RA, the deck, etc. Right? Now what happens is from this you'll get either the names if you don't know the names of catalogs or their their coordinates. You can feed that over here into the science archive, right? So there's M36, there's another globular cluster called M4. So if you put M4, it'll give you the coordinates for M4. Or I can even send you a list of clusters for which you can try out and you can get the data from here. Not all clusters are there. I checked out a few, not all are there. 2453 is not there. It's not there. But you will have to actually look for the clusters for which it is available. Don't forget to click include public data. Okay. And 2264, I think this is there. 2264, I think is there. No. Let me take 1893. So we actually need to see which are the clusters for which data is available. And accordingly, I'll just check those. And you can actually use that to download the data. If you are more comfortable with TopCat, then you can do it with TopCat. If you are more comfortable with Jupyter Notebooks, you are most welcome to do it with Jupyter Notebooks, right? And once you do that, you can actually, construct your color magnitude diagram. Like we showed you, if you want, you can construct the color magnitude diagram using TopCat, or you can construct the color magnitude diagram using Jupyter Notebooks, right? Either of the two. So what we propose for this is that you can plot and send me your your HR diagrams, as well as if you're doing it with a Jupyter Notebook, send me the Jupyter Notebook code, okay, that you've written to use the data and plot the things, right? So once we get that, then we can use that to give certificates or whatever, so that you can try using what we've done, right? I can see the question from Tushar Nagin. Can you please send all the links you share in chat? Having some network, that's why we did. Okay. So yeah, that's the problem with Zoom, that if you exit the Zoom thing, you lose everything that's there on the chat window. And therefore, what I'm going to do is I'm going to send you emails. And other than that, I will put up all these things on the website. So I've actually made a website, which I can show you, which is there. I forgot the website, this thing, but I'll just show it to you. 1 minute, okay. So you will go to our parent website, that's shrishtiastro.com. Right, and okay, no, it's not on projects, it's on home. Yeah, so you'll come to this. This is the website. So you go to shrishtiastro.com, scroll down, come here, here's the website, right? But at present on the website, I have only put the, the topics to be covered and stuff like that, registration link and all that. What are we going to be doing? But I will add over here all the other links, okay, at this website. For people who missed the lectures or came in late or would like to see the lectures again, what we've done is from the beginning itself, we live streamed this all onto YouTube. So all the stuff that we've done is directly available on YouTube. Click on this and here you'll see this is the live session which we are doing just now itself, right? So you'll have to go to the playlist which says photometry with LCO. Go on to this, telephotometry with LCO, view full playlist. This is yesterday's and today's thing will also come over here. So I'll add that over here and you'll get it. So please take people who are asking for the stuff, Tushar and all, take all that material from the website, because yesterday also I had this problem that I emailed things to people and then later on Zoom sent me a message that I have exceeded the level for, the amount for sending mails and all that. So that problem could be there. So anyway, you can go on to the website, go on to the YouTube channel, see the videos as well as this thing. Now, I would also like to request everybody that essentially we, sir and me, we teach at the university. We do this out of pure interest and therefore I will send you by mail also. But I have also made a feedback form basically because we would like to know from you, how did you find the workshop? What is the way to do it? Like one thing we realized is you cannot keep day-long workshops because people are getting tired of looking at screens. And that's why we decided to keep our workshop just for 2 hours on 2 afternoons. And we didn't do evenings, etc., because people could be busy at other times. So we thought it should be shorter, but we had to do it on 2 consecutive days so that you don't forget what we did the previous day. And that's how we planned it like this. But please do fill the feedback form. I'll send that to you by mail also, so that we actually know how do you think we can, thank Nora. How can we actually improve the quality that we are doing? So let's actually take a screenshot. So those of you all who are online, can you put on your cameras, please? We can have a nice screenshot and do send us in the feedback form things that you think would be better. Whether you think they should be done on evenings or for only 1-hour sessions or day-long sessions or whatever you think would be the the ideal way of doing it. Because the problem is everybody's tired with COVID and all the Zoom sessions that we did. Everybody's tired. So we actually need to see how is it best to, do these things. Yeah. So please get your, cameras on. I should have done it yesterday because yesterday we had hit 100. 100 people were there. Today we have lesser, probably because of Sunday, but we're still happy to see all of you over here. And do try to make your HR diagrams. Do tell us what do you think would be better ways of doing this so that it's more easier for people to follow. Dhanya, you want to say something? You can say that. Your hand is up. You're muted. Please unmute yourself. You have permission to unmute. Everybody can unmute.
Hello, ma'am. Good evening.
Good evening.
Actually, I have done my PhD on this topic only. This one, that spectrometry and all. Okay. And also some ideal software I have used. And I in the DS9 also I have worked. So it is very much informative for me. Some extra knowledge also I got.
Okay, good. That's so very nice.
In future also, if some help needed, I will contact in that regards.
Yeah. Sure. Yeah.
Okay.
Does anybody want to say something? Then that will be on the records. If somebody wants to say something, please let us know what you think. Many of you all are familiar faces. We see you all at many of our workshops. So hello to everybody, all old friends.
Hello. Yes. Can you hear me?
Yeah, I can.
Yeah, it's my first time to join this workshop, and I found it very formative and excellent in terms of the knowledge that you gave at the beginning, like the presentation you have started with, and with the practical session. So it's a very good workshop. So yeah, I'm very
Thanks.
happy that I have a chance
Thanks
to
a
attend.
lot. Thank you.
I would like to say something.
Please do.
Okay, great that you hearing me. Hi, my name is Sigrid. I'm actually from Namibia in the southern hemisphere of our world, and I'm right in the south as well, just next to South Africa. And I always tend to take part in this workshop of Dr. and Prof. Hasan, because they seems to be very convenient, as you mentioned, the time, and you guys just sort of give us the lollipop and then you pull it away. So I'm really learning a lot. I'm also an astrophysics master student. So, and I'm basically more based in gamma rays and high energy and radio. And we're having a lot of projects here, and these are the kind of things that we need. And me being one of the seniors, or probably the dummy, I'll have to help the rest of the youngsters in this manners. And it really, really is working and helping. Yeah, it's just time is a factor.
Thank
you very much. Please keep it up, and I think we should have more of these.
Yeah. Sigrid, you need to enjoy the lollipop, right?
But you're not giving it to me. You're just putting it in my face.
Okay.
Yeah, it looks beautiful. Thank you.
Yeah. So, see, basically, the idea is like one of them said, it's a lollipop. This is just to tease you, just to tell you what are the things available. And then you work on this, and you may have problems with the Jupyter notebook or DS9, and you can always come back to it. This is just 2 days are too less for us to give a complete thing. So this is just showing you what are the things which are available, how to access the data, what are the tools available, and you'll have to now sit down and try to work on it. And surely you'll have issues and problems, and you can come back to us and we'll see how best we can do it. In fact, you can form groups amongst yourselves, and you can work in group, and this has been most effective where your peers also troubleshoot you, not just us. But this is just to introduce you that these are the things which are possible, and these are the tools which you need, and then you have to choose which is most elegant, most beautiful for you to do and build on that. Yeah, this is just the beginning. And if you need, we can have a follow-up workshop. These 2 days is to show you where the data is available, how do you download it, what are the basic tools required to look at the data. You try that out, and if you want, you can mail to us, and then we can have another workshop where we can start doing proper science with this data in a more detailed way. Okay.
Tushar, you wanted to say something? Your hand is raised. Or whoever.
Yes, I'm audible.
Yes,
Hello,
yes.
I'm audible.
Yeah, you are.
Can I speak in Hindi if possible?
Yes, sure. We all speak Hindi.
हाँ, मैं ये पूछना चाहता था कि अभी आपने ये जो कुछ भी बताया, अभी 2 घंटे से ये सब कुछ बता रहे थे आप, वो कौन सी प्रोग्रामिंग लैंग्वेज में बता रहे थे? मतलब कि प्रोग्रामिंग लैंग्वेज बहुत सारी है, पाइथन हो गया, सी
ये पाइथन था।
अभी सब कुछ पाइथन में ही था।
जी,
पाइथन में था।
हाँ, थैंक यू। अगर उसके ऊपर कुछ आगे चलकर रिसर्च वगैरह करना हो, तो पाइथन की नॉलेज हो तो आप आगे चल कुछ भी कर सकते हैं, इसलिए मैं पूछ रहा था।
जी,
थैंक यू।
वो ओपन सोर्स है, तो वही आजकल सब लोग यूज कर रहे हैं। ठीक। Mohammed, you want to say something?
Yeah, thank you, Miss and Mr. Hassan. Really, it's my second time I'm with you in this workshop, and I'm Mohammed Taraf, a little responsible for a small telescope, if we say that, 43 centimeter And really, I'm try all what I learned already. I tried with my telescope, and I get the HR diagram. Really, it's very useful, your workshop, and I would like to thank you. And my colleague, Miss Noor Al-Amiri, she's one of the smartest, my colleague, and really she's, and now she's a master student. Really, I would like to thank you, and I'm waiting to see you, inshallah, in the next time, next 2 months, inshallah. Thank you
Yes.
very much.
Yeah.
It's a very good chance to learn from you a lot of things. We need to repeat and try, practice until we be a good astronomer. Thank you very much, really. Thank you.
Thank
We
you.
wanted to ask you
Please.
whether your students are familiar with Python.
Yeah.
Yes, yes. As a basics,
so,
yes.
So yeah, if not, then we can build it up from the basics.
Yeah.
And otherwise, we can just go ahead and use this AstroPy.
Yeah, most of them has a class of Python, and they are in the basics of Python. Some of them it's good in Python. It's almost for them it's easy, and we try and we practice in Python in some way.
Okay.
Okay.
11
11, ma'am.
Yeah.
Thank you. Thank you very much, ma'am. It was a very informative workshop because I actually have an LCO account and I have tried to do observations. But now I understood a lot, quite a lot. And one more thing is I'm one of the regional trainers for the asteroid search run by Isaac for the whole of India. And a major thing that's stopping students from participating is it works only on Windows.
Okay.
What I've been told is you can use any software which allows astrometry to generate the same report. So but I need to understand photometry in detail first before I can guide people into actually doing it on another software. So that's another reason I'm here. There is another person who does the asteroid searches here. Surariha is here. And I think, ma'am, you said you're from the Southern Hemisphere. I don't remember. I can't pronounce your name. So this is for all of us. I'm attending this for all of us. And I think I'll keep on getting back to you with my doubts till I accomplish it.
Yeah, but tell me, what's the problem in Astrometrica? People don't have Windows machines. They're using Linux,
Yes,
or you're using Linux?
Linux or Mac.
Yeah, but then you can actually emulate Windows, or have some kind of a virtual machine and maybe handle it that way.
Mac, now the problem is it does not support Wine. That is the most common Windows emulator. It's not supporting Wine. Linux, it's possible, but that emulator, it runs very slowly.
Yeah, actually,
and for anything, we need a copy of the Windows. For anything more, we need a copy of Windows.
Yeah, actually, even I, just out of interest, even I did some asteroid searching, basically to learn, to see how is it done, what's it done. Basically, I was trying out different citizen science projects. But yeah, I agree that is a problem. But one should actually tell the Astrometrica guys, they have to change it at their end, because the whole software with which you've given your report and all, that's all been done by them. So if you are working on a system which doesn't talk to their software well enough, you will have a problem. So actually, I think you need to approach those guys at that end, and they need to make it more in such a way that it's inclusive for other OSs. So typically, if their software were Java based, then they will not have this problem.
Miss, can I just maybe I have some of this experience in asteroid observation. I used already Astrometrica. There is a really very good software. It's called Tycho for asteroid tracking and discover. It's good, but it's you need to pay for him. I think $50. It's good. But for the Isaac, this participant, you already on it for looking and searching for the asteroid. You know this Isaac. They used Astrometrica.
Yes.
Most of them just use Astrometrica.
Yes,
I'm already
yes.
for 2-3 years with them, but now I'm really still Astrometrica is very good software, and now I'm use both Tycho and Tycho make your astrometry and photometry. And for just astrometry, AstroImage, there is a third software, AstroImage, but it's not for asteroid. Just for you can use it for astrometry for some reason. This is, but Tycho, it's a strong software for this.
Okay.
And for the girl from Namibia, I'm just when we say Namibia is the best sky all over the world. There is no pollution, nothing really. It's one of my dreams to visit Namibia to observe from the. Really, thank you very much. Thank you very much. This is the conversation. Get some new ideas and push us for new thinking. Thank you very much.
Yeah, yeah. So thank you everybody, and see you again. I'll be mailing you all the links and the feedback form. Please do fill the feedback form so that gives us some indicators, right? And yeah, see you everyone.
See you.
Bye bye. Bye bye.
Hello, ma'am.
Yeah. Sorry.
Can you hear me?
Yeah, I can.
Yes. So, ma'am, I was actually asking for the big research projects which then sir mentioned, like some advanced projects where we can actually work on hands-on data, process those things with the pipelines and all these things, softwares you taught, and we can publish some research paper type thing. So can we have a project on that where you people can guide a few of us? Actually, there are many interesting students from our college. I am from Ferguson College, Pune, Maharashtra. And there are many interesting people. Some of them were here. I guess they left. But we are interested, 5 to 6 people, we are interested in forming one group and having a good research project under you both. So can we have that in future sometime? Maybe after this Diwali vacation or so, when you have some convenient time slots.
Okay, so you basically you all have to work. So you start working, yes, and then you see what happens, right? So you all need to organize and work, and we can.
So we can of course do one thing. First, we'll go through these basics in upcoming maybe 2-3 weeks slowly, and then we can mail you about some advanced thing.
Yep.
We can have it.
Fine.
See, the previous workshops which we have done, some students have done projects.
And they've actually published papers also.
Yeah.
Okay.
The previous projects.
But they were consistently working for a long time.
Yeah, you can't take Diwali break and that break and this break. And
no, I was just talking about the not exactly break, but we can cover the basics or the things which you taught in this period, and then we can have some project.
Yes, that's fine. That's fine that you can do that.
So that was my plan.
Yeah. Okay.
Thank you. So we'll surely contact you.
Yeah.
In few weeks, and then we can think of a big project. Thank you. Thank you so much.
Yeah. Okay.
Thank you, sir.
Yeah. Okay. Fine then. So see you everybody. Bye bye. Yeah. Keep in touch. I end it.
Ma'am, I'm audible?
Yeah.
Hello, ma'am.
Yeah.
मैं ये पूछना चाहता था कि अलादीन करके एक सॉफ्टवेयर आता है, क्या उसके ऊपर भी आप क्या इस तरह से वर्कशॉप या गाइडेंस के लिए कुछ कर सकते हैं? ऐसा कुछ
हम लोग कर चुके हैं,
अरेंज कर सकते हैं?
हम लोग ऑलरेडी कर चुके हैं। यस, तो हमारे YouTube चैनल को अगर आप जाएंगे तो वहां पे आपको भेजा है मैंने, तो वहां पे अलादीन के साथ भी चीजें हैं। तो वो भी जैसा DS9 डिस्प्ले करता है ना, DS9 जो आपने देखा ना डिस्प्ले कर रहा था इमेजेस को, उसी तरह से अलादीन भी डिस्प्ले करता है इमेजेस को, लेकिन उसके फंक्शनैलिटीज में थोड़ा फर्क है बिटवीन DS9 एंड अलादीन। बट बेसिकली वो भी डिस्प्ले करता है इमेजेस को, और आप ओवरले कर सकते हैं कैटलॉग्स को, इमेजेस को, कई चीज़ों को। ठीक है, तो आप डाउनलोड करके ट्राई कीजिए आप।
और हमारे थैंक यू
कवर किए हैं पहले।
हाँ, हम लोग ने कवर किया है पहले, हमारे वेबसाइट को हमारे यूट्यूब चैनल में देखिए, वहाँ पे है। ठीक है, ओके ओके, चलो।